Hello, the moment you've all been waiting for, our last lab on Eagle uh, printed circuit board creation tool. So this week I called this lab Pulling It All Together because what you're going to do is take it from the beginning step, creating a schematic, identifying parts that you need, creating library components, and then finishing off with an actual layout of the circuit board. So again, we're going to follow the methodology for creating a circuit board that we talked about last week in the library lab. So you'll, as you're constructing your schematic, first you'd create a board by hand on a proto board, identify all the parts that you have, then go into Eagle and begin creating a schematic for it. And as you do that, identify the parts which are not readily available in the libraries provided by Eagle. The next thing you would do is create your parts using Eagle in a library that you create, and then complete the schematic and then create the layout according to the rules that are given. So this is the schematic that we're going to create. It's a voltage converter. It converts a low voltage that you might come in here. This might be from a source like a solar panel or a Peltier device or something that creates a small amount of voltage, but in order for it to be useful you need a constant 3-volt source, for instance, to power a chip like a microcontroller. So the way this works is this generates power. When this transistor is on, current can flow through the transistor, through this inductor, through the transistor into ground, and as it flows through the inductor it stores energy in the inductor. When the transistor is shut off, this becomes an open circuit, and now the only place for this current to go is into this capacitor. So what's happening here is that the voltage is monitored. This is my 3 volt stabilized side is monitored by the microcontroller. When the voltage drops below a certain value, it sends another pulse out here to the transistor, starting the process again, charging up the inductor, shutting it off, charging the capacitor, maintaining a constant voltage here. Okay, so we're going to create this, and we're going to use a library that is in Moodle, Lab 8 library, and there's several of the components are in the library that you'll use. You'll just drop those in like you normally would, but 3 of them are not in the library, and so you're going to have to create those. Okay, so that would be the U4 device, this inductor, U5, where's U5? Anyway, it's here somewhere. And then the U6 device, which is this potentiometer here. And I've indicated the way these things should look in the symbol view and in the layout or package view. Okay, so I'll start dropping these into a schematic. So I've got a folder on my desktop, and that folder has the library downloaded from Eagle. So file, new schematic. Before I use it, I need to tell Eagle to use the Lab 8 library. And now I can start dropping components down. Okay, so go ahead and create that schematic as it is in the document. And then when you're done with that, we'll create the library. Okay, folks, so now I put my schematic together, and I did so minus the parts that I don't have in the library that I have. So those are the ones that are in the table here in red. So what I need to do now is create those parts and complete the schematic. So the first one I need is this inductor, which is the inductor here, the U4 device. And what I want to do is use a symbol that looks like this. I'm going to do something a little different this time. I'm going to go to get an existing picture or symbol view, and I'm going to copy it into my library. So instead of creating it from scratch, I'm going to copy it. So I'm going to go to the RCL library and copy that. So I'm going to close my schematic. Now I have to find the location of that library. Right now it's only opening up my library, so what I need to do is find where that thing is. Where is that library? Buried somewhere in the computer. Somewhere on the C drive. It's probably a program file. Eagle library, and there's all my libraries. And it's RUS. It's a symbol. Oops. LUS. There it is. Okay, so I want to copy this into my library, into my Lab 8 library. So what I'm going to do is select it all. Copy with the right click. Now I'm going to go out here into my view, and now I'm going to right click, copy group, and now I've got it. If you don't see this moving around, you haven't got it. So now I'm going to open up my library. Open recent. My Lab 8 library. I want a new symbol. I'll call it LUS. And now I'm going to paste it in with this yellow thing down here. And there it is. Put it right in the middle. Okay, so now I have that image from the existing library. Save it. So I've got the symbol. So now I need to create the package view, and what I'm going to do is copy an existing package from my existing Lab 8 library. I'm going to copy it into another package, and I'm going to use it for an inductor. I'm going to make it look like this. I'm going to copy this one from my library and make it look like this. So package, I'm going to take my R300, so that's the one that currently exists, and I'm going to copy it the same way I just did the schematic. I'm going to group everything, copy with these two guys, and now right click in the field, and there I am. And now I'm going to create a new package, call L375, because that's how far apart I want the pads. And now I'm going to paste that one in there so I can use it as a guide. And now in here I need it to be 375 apart, and I need these circular. So I'm going to just go ahead and modify those. Okay, so that's about 375. I can't get 375, but those are about 375 apart. Now I'll put in my okay, so now I have my two parts. Now I need to make it into a device. I want it to look like this in my view. And now I'm going to create a new variant. I'll call it the same thing. Connect them. It doesn't matter how they're connected. So now I'm connected. Save, I can use it. I'm all done with that device. Now I'm going to create the pot that's missing from the schematic. This one. So I'm going to go to the pot US library and get this symbol. To go to my Eagle libraries, and remember those are on the C drive in program files, Eagle 5.1 or whatever 6.1, and then in the libraries. Let's see what symbols I've got here. Is that the one I wanted? Yep. Okay, so now I need to copy it. Now open my library, Lab 8, a new symbol. And now I'm going to create this from scratch. think what I'll do is rename these first, these pads, so I know which ones. That's E, S, A. So that's E, S, A. So I need to remember that it doesn't matter which I connect to these, but this one is important. I need this to be S. New package, 3-pin device. And how far apart were these supposed to be? Pads 0.2 inches apart. So let's create that package. I'll call it pot 2 for 0.2 inches. I'll say 200. I need 3 pads. I always favor the big ones because they're easier to solder. Let's name them. Make it look like it did in the diagram here. Something like that. Now I need a new device. A new variant I'll call and it's these two that I've got to make sure are connected. The 2 S ones, because those are the wipes. Okay, it's done. Last one. I'll let you guys make that one. So you're going to steal it from the NPN library and create the layout from scratch. Just be aware that's B, C, and E for the collector, emitter, where that arrow is pointing to, and the base. And you can select that as being the emitter, base, and rightmost C, with the flat side shown. Okay, so we've got our 3 parts done. Now we're going to put them in the schematic. So again, I'm using library 8. Make sure it's connected. And the one I made without you guys, my transistor. Oops. Made 2 of them there, I only want 1. Let's see where these go. Name this one. And everyone's connected. All right. So now I'm done with my schematic. I've got all the parts I need in it. And now I need to create a layout. And I need to do so with 24 mil wires, except 32 for the power and ground. Okay, so I've created my layout, and now I've positioned everything as I want it. And I need to make sure that it routes it automatically on the bottom layer such that all the lines are 24 mils, except for the power, ground, and the 2 power nodes. There's 2 of them because this converts one voltage to another. Those are all bigger at 32 mils. So let's see if we can do that. DRC, I need to change the rules first to 24. And now when I auto route, I need to make sure these are all NA except for the bottom. Hit go and see if it can do it. All right, it did it. So now let's find my power nodes. If I click on a node, this is V+, so this has got to be, everything connected to this has to be at 32 mils. So I need to edit, change width to 32. What else is connected to that one? Just that one. I believe that's ground. Yep. So this whole node needs to be 32. Does that cover everything? And there must be one last one here. My 3-volt node, everything connected to these pins needs to be 32 mils. Might be getting a little tight in here. So what I'm going to do is move it. This is tight. Okay, so now for the report, you're going to submit your schematic view, your layout, and your bill of materials. So good luck, and next week we'll be on to another thing.